Okay, let's take a look at question number 11 from homework 7. This one, I'm going to be absolutely honest with you, is not very straightforward. You've been doing math pretty much your entire life, so you have an idea of how to do things when you see them. Or at least you have a best guess of how to do things when you see them. And this is one where you might not be able to guess exactly what needs to be done. So let's go through this. We're going to go through it slowly, step by step. I'm going to be color coding this so that you have another way of organizing things. Also, I'm going to recommend that you watch this video from beginning to end without trying to solve the problem. Don't solve along with me, just watch it so you can see what I'm doing, the steps that I'm taking, and then go back and watch it and try to do it, because this is just not the way that you would go about solving questions most of the time. So definitely follow along slowly. And once you've got this down, once you've gotten the correct answer, go and find one of the practice and drill questions or two of the practice and drill questions on WebAssign and do those just to cement this, to make sure that you've really got the procedure down. Okay, so the question says, for the following demand equation, compute the elasticity of demand and determine whether the demand is elastic, unitary, or inelastic at the indicated price. Round your answer to 3 decimal places. Well, I will love to round my answer to 3 decimal places, but first I've got to get an answer. So let's get cracking. We've got P equals 181 minus x squared. Your numbers may differ. This is what they've given me. And also P equals 25. Okay, what next? What do we do? What do we know? Go for something you know. You know that there is a formula for elasticity, this E of P thing. And you've seen this in lecture. It's in the lecture notes on Moodle. What it is, and here's where I'm going to start color coding things. It's negative P, so we're going to have a P somewhere, times F prime of P. Okay, and that all goes over F of P. Okay. So this is our formula, and it's got 3 different pieces, 3 different colors so that we can keep track of it. E of P equals negative P times F prime of P over F of P. Okay, so what do we need to find? We need to find P. We need to find F of P. And we need to find F prime of P. These are all the pieces that we need to solve this puzzle here, basically. Okay? Good news is they've given us one of the pieces already. They've told us that P equals 25. I like that. That's pretty easy. So I've been able to fill that in. But now what to do about this F of P? Because I don't have an F of P anywhere. They didn't give that to me. What you need to know is that X equals F of P. And we've got an X hanging around up here. So we need to figure out what X equals, and that will tell us what F of P is. So we need to solve this equation here for X. So let's do that. We have P equals 181 minus X squared. I want to get my X on one side and everything else on the other, so I'm going to change that to X squared equals 181 minus P. If I take the square root of both sides, that's going to give me X equals the square root of 181 minus P. And since I know I'm going to need to find F prime of P later, let's get rid of that square root sign altogether, and we'll just use the fractional exponent. So that's going to be 181 minus P to the 1/2 power. Because if you have something that you're taking a square root of something, that's the same as saying that you're raising that thing to the 1/2 power. Okay, I've got it. I have F of P. So I'm going to go ahead and fill that in because I found X, and I told you X equals F of P. So this is 181 minus P to the 1/2 power. Now we need F prime of P. Okay, well I can do that because I've got F of P. Let's go ahead and write down what F of P was here. So we have F of P equals 181 minus P to the 1/2. We've got to do the chain rule, but that's not the end of the world. We know how to do that. Bring down the exponent, 1/2. Copy exactly what's inside the parentheses. So that's 181 minus P. Lower the exponent by 1, so that's going to make that be to the negative 1/2. and then multiply times the derivative of what's on the inside. The derivative of 181 minus p is just going to be negative 1. I can simplify that a bit. So I have, let's see, I'm going to multiply the negative 1 times the 1/2. It's going to give me negative 1/2 times 181 minus p to the negative 1/2. Okay, I have f prime of p. I just figured that out. So negative 1/2 times 181 minus p to the negative 1/2. I needed p, I've got p. I needed f of p, I've got f of p. I needed f prime of p, I've got f prime of p. Now I have everything that I need to solve this function. Okay, so let's go ahead and do it. We need e of p, but we know p is 25, so I'm going to do e of 25 down here, okay? We need e of 25, and that equals, well, let's see, p, this guy right here, that equals 25, well, negative 25 times f prime of p, okay? So we have f prime of p, but remember, p is 25, so I'm just going to go ahead and plug in my 25 when I write this out. That would be negative 1/2 times 181 minus 25 to the negative 1/2 power. Okay? We're going to put all of that over f of p. So f of p, we've got this here. Again, I'm just going to plug in my 25 while I'm writing it out because I know that I'm looking for e of 25. So that's going to all be over 181 minus 25 to the 1/2 power. This here, you can plug into your calculator. You can simplify it a little bit before if you want to, but you can plug this into your calculator. Be careful with your parentheses. When I plugged this into my calculator, this exact thing, I got 0.080128, whole bunch of other stuff. They want that rounded to 3 decimal places, so that's 0.080, and that is actually the answer that they're looking for. Then they also want to know whether or not this is elastic or inelastic or unitary. Well, we know that if it's less than 1, if the answer to this function right here is less than 1, that it is inelastic. So because mine is less than 1, I have 0.080, this is inelastic, and that will be the answer to that part of the question. So what I'm going to do now is go back through step by step to make sure that you understand, and then you can go back and watch this again and try to solve alongside. So they gave us p equals 181 minus x squared, and they also gave us p equals 25. We need to find elasticity, so we're going to use the elasticity function. That's e of p equals negative p times f prime of p times f of p. So we had to find all of those pieces to be able to solve this. They told us that p was 25, so we had that right off the bat. We needed then to find f of p, and I told you, and it's in the course notes somewhere, that f of p is the same as x. And they didn't give us an f of p, so we have to solve whatever they gave us in terms of x. And they gave us this guy here, and so we're going to solve this in terms of x. So I brought it down, I solved it, we wound up with a square root, we changed that square root to a fractional exponent so that we could take a derivative. And then for the derivative, we just used the chain rule, brought down the exponent, copied inside the parentheses, lowered the exponent, multiplied times the derivative inside the parentheses, and then simplified it a little bit. That gave us the last piece of our puzzle, so now we just wrote this out in terms of what we needed. We needed e of 25, so that's going to be negative 25 times our f prime of p. We just plugged in 25 for p here because we knew that's what we needed, and then all over f of p. So that's negative 181 minus 25. I plugged in my 25 for p to the 1/2. Plug it into your calculator, you will get an answer. If your answer is less than 1, it is inelastic. If your answer is greater than 1, it is elastic. And if it equals 1, it's unitary. If you have any questions, shoot me an email, but definitely practice this one. This is one you might want to watch a couple of times just to be sure you've got it down. And that has been Actually, this is probably take, I've got a whole lot of scratch paper here. You see this, guys? That's been take, I think, probably about 8 on trying to solve this problem for you. Oh, that's not the right scratch paper. But I've done this a lot of times to get it right. So don't feel bad if it takes you a few times to get it right yourself. All right, on to the next one.